Hi, this is Kevin. Welcome to my lecture on um, Chapter 8 of the Zelle 3rd edition Python book. Chapter 8 is about loop structures and booleans. There are going to be two parts of the lecture. This is part 1. So first we come to the objectives of the chapter. I'm going to leave those for you to read on your own. So, for loops, a quick review. So, we've been using for loops for a long time in the book and in my course. I think we may have even used a for loop in week 1. When we got to chapter 5, we looked at them in more depth. Okay? And here we're going to be talking about them again. So the for statement, I sometimes call it the for in statement or for in construct, allows us to iterate through a sequence of values. And it's for a variable name and sequence name. Okay? And then there's a body of code, one or more statements that make up the code block associated with the for. The loop index variable at this point called var takes on each successive value in the sequence, and the statements in the body of the loop are executed once for each value. Suppose we want to write a program that can compute the average of a series of numbers entered by the user at the console. To make the program general, it should work with any size set of numbers. We don't need to keep track of each number entered. We only need to know the running sum or total and how many numbers have been added. We've run into some of these things before. A series of numbers could be handled by some sort of loop. Probably a for loop to begin. If there are n numbers, the loop should execute n times. And again, n is not a great variable name, but it's a good kind of algebraic or mathematical name. And so it's appealing to the author, and we're going to go with it. We need a running sum or total. This will use an accumulator. So we're going to be using the accumulator pattern. I think we first talked about the accumulator pattern in chapter 3. And this is going to be the kind of accumulator that works for addition and subtraction. So here's some pseudocode. Input the count of the numbers, n, that's the variable name. Initialize the sum to 0. You're going to see pretty soon that we're not going to use the variable name sum because that has some problems. We're going to use the variable name total. Loop n times. Input a number. We're going to call that x. Again, is that a great variable name? No, it's kind of algebraic, but we're going to tolerate that. We're going to add x to the sum or the total, the accumulator, and in the end we're going to output the average as the sum divided by n. And I'm just going to point out that my refactor version of this program is going to be just a little more complex than this, and I'll show it to you in a minute. So here's the code for average 1, okay? And instead of looking at it on the slide, I'm going to pull over the code that was delivered with this edition of the textbook. And the comments were a little bit different. Interestingly, it didn't use sum. And one of the reasons, I guess the last version of the code used some, that's why it's on the slide. But if I use the word some here, I'm going to get a warning that it shadows the name of a built-in function. So it's not a good practice, okay? And generally speaking, when we're using a PyCharm in my class, almost everything that gets a yellow squiggly underline, we're going to fix. So we're going to undo this and go back to the total that they have. Okay, and there are a couple other logic problems and such. For instance, here's the main problem. He's going to print a total as total, which he's accumulated, divided by n, which is fine if n's not 0. Now, I think we may have talked about this before, but even if we haven't, division by 0 is undefined. Okay, the answer is not knowable, and in most programming languages, if you divide by 0, you get a divide by 0 exception, and the program blows up. Okay, so this design that we have here and the pseudocode that inspired it are not really robust enough for us. So here's average 1 refactored. Okay, what have we done? Well, we got rid of the comment that that just had the name of the program file, and we've created a doc string, a program to average a set of numbers, and now we have a series of these. I think we have 7 of those called average 1 through average 7 that we're going to look at. And so we need to be able to distinguish among them. And so we have a little bit more detailed information in the doc string. Illustrates a counted loop with an accumulator. Okay? And we're doing things pretty much the way that we have. Oh, I want to fix one more thing. See where he calculates the total. He's not really using let me make that code just a hair bigger. He's not really using a practice which I recommend to my students, which is whenever we are adding to a value, you can express it like this, or you can use the plus equal. So we're going to use the plus equal. And why? Well, we're going to do it the same way in all of our programs. So this, total plus equal x, is the same as total, because assign the value total plus x. Okay, that's something I missed in the refactoring. Okay. Another thing that I like to do, at least in my teaching programs, is I've got this kind of initialization that goes on. And if I have a loop, I tend to want to separate it by blank lines. I want it to be clear to students where the loop's going to start and where the loop ends. Students traditionally have problems with accidentally getting the statements to come completely after the loop, accidentally tagged on the code that's in the body of the loop. So I kind of like to do it like this. Now, I just want to point out that a lot of the changes that I make here are not really feasible for a textbook author who wants to create either a program that fits easily on a printed page, and especially a program that fits on a slide where historically slides have had type that's large enough to be read in a classroom from the back row. Okay, and maybe this type's a little larger than it has to be, but that's it. So this really forces you to make a lot of compromises in your code that are maybe important for the author in order to get the slide to work, but they're not good practices for the student. So as you can see, this program is a little wider. Some of the names are a little bit longer. This program is a little bit longer, but this is our kind of standard of coding. It's our standard of care that we're going to have. One other thing that we've done here at the bottom is that we check if n is equals 0, because if it is, we don't want to divide by 0. We want to print out a polite a message. In this case, the average of 0 values cannot be calculated. Okay. Else, well, then we print out the sentence that has the answer. And the good practice these days, when you're formatting a line that includes plain text and values from variables, is to use an F string. So that's what we're doing here. So let's give this a run. Okay. So we're going to run, how many numbers do you have? Our first test case is going to be 0. The average of 0 values cannot be calculated. And then let's just do another case would be 1, okay, $9.99. The average is 9.99. And then let's do 3 values, okay. Enter a number 1.11, 2.22, 3.33, and the average is 2.22. Well, that seems to be working fine, okay? And we do this with what we essentially have is we have your basic counted loop, and we've just made it a little bit more usable by prompting the user for the number that we're going to count to. Okay? Pretty straightforward. Okay. Now, we can do a little better, okay, and we're going to do that. So the program we just took a look at, it got the job done, but you need to know ahead of time how many numbers you'll be dealing with. What we need is a way for the computer to take care of counting how many numbers there are. The for loop is what we call a definite loop, because it's going to execute a definite number of times. We can't use a definite loop unless we know the number of iterations ahead of time before we start the loop. That's what we mean by ahead of time. We can't know how many iterations we need until all the numbers have been entered. Well, we can count up the entries that we have to add, and if you have 4 or 5 entries, well, that's fine. That's not too hard. But let's say you've got 3 pages of entries. It's very challenging to count them accurately. So we need another tool, and by tool we need another design technique or design pattern or sub-pattern in order to take care of this. And what we need is the indefinite or conditional loop. It's going to keep iterating until certain conditions are met. So this is the first time that we're seeing an indefinite rather than a definite loop. So the general form of the indefinite loop in Python is the while. And it takes the form while, and then there's a condition. And we'll talk about conditions in a minute. They're the same kind of conditions that we used in Chapter 7 for if or if, elif, and those kinds of things. And then we have the body of code, which again is 1 or more statements. So the condition is a Boolean expression, just like with if statements. Semantically, The body of the loop executes repeatedly as long as the condition remains true. When the condition is false, the loop it terminates. Okay. Now, the condition is tested at the top of the loop. So here on slide 14, we see a programmer flowchart. And the warning that I always like to give with programmer flowcharts is that these are good tools for teachers to show students how programming logic works. We've really stopped teaching students the programming flowchart language for their own use because we consider pseudocode to be a better tool for sketching out your program code. The problem is that the programming flowchart language allows you to diagram things that are not kind of approved program structures. Okay, but for me to show you an approved program structure in a programmer flowchart, just what we need. So one interesting thing about the while loop is it's a test before or a pre-test loop, which means it's possible for the body of the loop to be executed 0 times. Okay, because what happens is we come into the loop of a construct, we test the condition. If it's true, then we do the code in the body. If it's false, then we go to the next statement in the program after the while loop. Here's an example of a while loop that counts from 0 to 10. So we initialize the variable I to 0, and then we say while is less than or equal 10. We have the colon, and we've got 2 statements in the body of the loop, print I, and I gets assigned I plus 1. Okay. And we run around there, and we're going to print the numbers from 0 through 10. Okay. Now, a couple of points to be made here. One, we could have done that with a for loop. Okay, we could have said for I in range 11 print I. Okay, and that's better Python. Okay, because we're using a built-in function. It's less code, it's easier to read. But if we wanted to know how this bottom code would be implemented if we coded it by hand using a while, well, it would be the top code. And one interesting point, well, a couple of interesting points. One is that in order to have a properly designed and coded while loop, the state of the expression that you're checking has to change in the body of the loop. Okay, this only terminates because we keep recomputing the value for I that we're testing in the while. Okay, if either we forget to recompute the value of the variable or variables that we're testing, or we accidentally code this condition wrongly, we could get into an infinite loop, and we'll talk about that in just a minute. It just to emphasize again, the hand-coded loop using a while is only there to show you the mechanics of a while and what the equivalent for would be. In your normal programming, if you can use a for, use a for. The while statement is simple, but yet powerful and dangerous. They're a common, these whiles are a common source of program errors. So, uh, as I suggested earlier, it's possible to forget to update the variable that you're checking, the variable or variables that you're checking in the condition that controls the while, and create a run-on or infinite loop. When Python gets to the loop, it's equal to 0, blah, blah, blah. It just keeps going. It's an example of an infinite loop. Okay. What should we do if we're caught in an infinite loop? One, take a breath. Okay. First, try pressing Control C. If that doesn't work, try Control Alt Delete. If that doesn't work, push the reset button. Okay. Now, I just want to point out that in PyCharm, there's a way to do it. So I'm just going to create a new program here, a new Python file called Infinite. Okay. And let's have a main. Okay, and right now we just put a pass in there to hold the place. And let's have a call to main. Okay. And so let's do the same thing. Let's say I gets an initial value of 0. Okay, and then we can say while I is less than or equal to 10, print I. Okay, so that's a decent infinite loop. Too many blank lines before. Okay, and we probably would have a doc string and all that kind of stuff up there. Okay, so if we go to run this, it's going to run infinitely, run infinite. Okay, and we can see the zeros printing away, and the program is able to issue the prints a lot faster than they can print. After a while, they don't even look like they're printing. How do you stop these in PyCharm? See the red square button that says stop infinite, and it says it on the Mac it's a command F2, so on Windows it's probably a control F2. Click on that. That's what will stop the program with a keyboard interrupt. Okay, because so that's what we use in my class. Okay, and now I'm going to take this out. Well, I can leave it right there. That's fine. Okay. All right, so we're not going to do the infinite loop. I'm going to tell you that you're going to do it. Okay. I've done it more than one time in the last year, and I've been a programmer for more than 50 years. Okay. Everybody does it from time to time. Okay. Keep your eye out for the telltale signs, and be prepared to stop them when they get control. All right. Okay. Now, another thing that we can do in terms of kind of improving this kind of program that calculates the average of a series of numbers is we can improve the usability by creating an interactive loop with the user in which the user is able to tell us in a somewhat easier way when they want to stop. Okay. So here's what we're going to do. we're going to, in addition to keeping an accumulator, we're going to use, and the slide here says another accumulator called count. Now, in our textbook, Zelle really makes no distinctions between accumulators and counters. And in my mind, accumulators are things that we accumulate values in, and the values are not one every time. And counters are kind of the trivial case of accumulators in that we're counting up by one at a time. So I prefer to call these counters because I think that's better communication amongst ourselves. At each iteration of the loop, you ask the user, or the program asks the users, if there is more data to process. We need to preset it to yes to go through the loop the first time. And that's kind of interesting. Sometimes you'll before you start a while loop, you need to initialize some value that's used in the while condition in order to make sure that you execute the loop at least one time. So here's the pseudocode. Set more data. I guess that's his idea of what the variable name is to yes. While more data is yes, get the next data item, process the item, ask the user if there is more data. Okay. Combining this interactive loop pattern with accumulators for sum and count, and I would say an accumulator for the total and a counter for the count. We have to initialize the total and the count. We have to, before we start our loop, we have to set our control variable more data to yes. While more data is yes, we input a number, we add it to the sum, we add 1 to the count, we ask the user if there is more data. Okay. And of course, when there's no more data, we're going to drop through out of the while, and then we're going to output sum divided by count. And again, he doesn't have a lot of room here, but one of the things that I discussed before is we shouldn't be trying to output sum divided by count if we didn't get any entries. Again, when you're trying to create slides like this, the real estate you have is very limited, especially when you make sure that the people in row 10 can read the code on the slide. So that brings us to average 2. And again, instead of showing the slide version, I'm going to show you a version of this in PyCharm. So this is average 2 as we get it from the author. And I think I'll make this a little bigger. Okay. And again, we've got the more data, we've all this kind of stuff. Okay, so I've refactored this, and let's make this a little bit bigger. Yeah, it just fits. So the doc string, the part that's different, illustrates interactive loop with an accumulator and a counter. Okay, and because I had a little more room, I put a blank line in for drama between this initialization and the loop, which does most of our work. Okay, and then at the bottom, I use the same code that we had from the prior version. If the count is equal to 0, then we're going to print a warning that we can't calculate that. Otherwise, we're going to print the average. Okay. Now, whatever code he had um, wasn't really robust enough for me. Let's see, what did he do on this while? Oh, he said while more data index 0. So while the first character of the string more data is a lowercase y, we'll continue on. Okay. Now the problem is, and we'll see this in another couple of versions of this, that uh, they might try to they might type this in lowercase, they might type this in uppercase. So here's what I decided to do. I decided to call the lower method of the string more data to make sure that if they typed in a capital Y or a capital YES, that I still would catch it. Okay, just a little bit more care. I've turned these two to plus equals. Okay. And then we've got this, uh, uh, we prompt the user at the bottom. Do you have more numbers? Okay. You'll notice that we preloaded this so that the first time through, we would execute it at least once. Okay. And those are the changes that we've made, and let's just test it. Okay, enter a number, 2. Do you have more numbers? N for no. Okay, so one thing that's maybe a little bit hinky about this current design, and it's not really fixable if we use kind of the pattern that the author is using, that there's no way to say, oh, stop, I didn't want to add numbers at all. There's no way to enter 0 values. Okay, and this, if you haven't figured this out yet, we're going through a series of versions of this program, and we're not suggesting that early versions are versions that you would want to adopt in your professional work. Okay, we're going to get to one or more of the later versions and say this is the approach that you should always be using. So the fact that this can't handle 0 entries is maybe sort of a negative a point about how far we've come in the design, but it's not tragic because we're not going to stop here. Okay, so that was average 2. And now the problem with average 2 is that it's a pain in the ass. If we just go back one slide here, you see every time we enter something, we have to answer if we're done. Okay, we did have the nice flexibility that we could type in several versions of Y or yes or yup or blah blah. Okay, that was nice. But this asking every time through if you want to continue is bothersome to the user, and that's really low usability. Okay, so there's a couple of reasons why we don't want to stop on the solution as we've designed it so far. Okay, now a really promising approach is something called a Sentinel loop. So what's that? A Sentinel loop continues to process data until reaching a special value that signals the end. That sounds promising. The special value is called the Sentinel. The Sentinel must be distinguishable from the data since it's not processed as part of the data. Still sounds promising. So here's some brief pseudocode. get the first data item. While the item is not the Sentinel value, process the item, get the next data item. Okay, so the first item is retrieved before the loop starts. This is sometimes called the priming read, since it gets the process started. And this use of the word priming comes from priming the pump. What a lot of people don't know about water pumps is, the old-fashioned water pumps that you would see on sort of American Western dramas where people lived in a little house on the prairie. The pump had a handle and that you pumped. And typically when people went out, they'd walk out of the house to the pump and they'd start to pump the handle and it would pump water right away. Well, that's only because it had been recently primed. There has to be a solid column of water from the pump all the way down to the water source in order for the handle to bring up the water with every pump. If they had been away from the little house on the prairie for a year and they came back, all or some of the water in that pipe that went down to the water source would have evaporated. And they would have to get a bucket or two or three or four, go down to the water source, and then pour it into the top of the pump, thus priming the pump, getting it ready to operate. So this, getting the first data item before we get into the while, is priming the while. It sets conditions for it to work. Okay, that's why we call it a priming read. If the first item is the Sentinel, the loop terminates and no data is processed. So a really nice thing about this design is it's robust enough to sense end of data in the first attempt to read. Otherwise, the item is processed and the next one is read. So this will work for 0 values, 1 value, 5 values, 5,000 values. So Sentinel loops are a big part of the design that we're going to adopt. Okay? In our averaging example, assume we are averaging test scores. We can assume that there will be no score below 0. So a negative number will be the Sentinel value. So now we're going to do average of 3. And again, I'm going to bring over the real code version of this. Okay? Average of 3. And the only additional problem that the average of 3 has in the author's version is this. In a lot of the programs that we do in my class and in the earlier and later programs that we do in the textbook, when we prompt the user for input, we just have a colon and a space after it. And this idea that all of a sudden that we're going to be showing them the double greater than sign may be visually appealing, but it's confusing to the user. So you'll be able to see that I don't adopt this. And there's another opportunity that I'll show you in a minute. Okay, so here is the refactored version of average 3, and as you can see, between the changes I made in the code and the changes I made in the comments and the changes that I made in the kind of formatting of the lines of code, this is really would be too big for the textbook page and challenging for the textbook page and too big for the slide. So we have to excuse the author for cutting a corner or two. Okay? Now, the only other thing I've done the same thing, except that if you go back to average 3, you can see that he's prompting the user for input here, and he's prompting the user here, and that's the exact same code, right? So what I've done is I've refactored and extracted the method such that we call a method called, a function called getUserInput. We call it from line 11 to do the priming read, and then at the bottom of the body of the loop, we call it again on line 16 to get the read that's part of the while loop. And we just put the code down here. And as you notice, I'm using a colon instead of that fancier but inconsistent double greater than sign. Okay. Priming read. Okay. Then the condition is saying while x, again, not a great variable name, but we'll allow that. While it's greater than or equal to 0, well then processes it. Okay. All right. But if we get a negative value, well, that means we want to stop. And if these were test scores, and typically on test scores are from 1 to 100, and negative values are not proper values, well, this would be a pretty good solution. Okay, so let's go to test this and see if it is going to test. What happens if we're done right out of the blocks? -1. The average is 0. Values cannot be calculated. That's just what we wanted. That's great. Okay, now I seem to have lost my left edge of PyCharm. Here we go. Okay, so we're going to run it again, and let's give it one value, 999. Okay, and then we're done. So let's say -77. Okay, and that's fine. It stopped. Okay, and it does one value well. And then let's do 3. So enter a number 1.11, 2.22, 3.33, -999. Stop. Average is 2.22. Well, that's working just fine. Okay? R80. You're going to make that a little skinnier so it fits on the next time. All right. Let's see if there's anything else that we wanted to where we want to pick up. So this version provides ease of use of the interactive loop without the hassle of having to type Y all the time to say that we've got more data. That typing Y all the time is a usability nightmare. There's still a shortcoming. Using this method, we can't average a set of positive and negative numbers. So if we were trying to say balance a checkbook, okay, instead of average test scores, or I guess the checkbook we wouldn't want to average, but let's say we had some kind of experiment and we were going to get number values as each of the observation, and they could be negative or they can be positive. Well, the approach that we just used, having a negative value being the Sentinel, that's not going to work. Okay, and you're thinking, well, there's got to be a way to do this without having the Sentinel be a number, and it turns out there is an easy one. We could input all the information as strings, okay, and I just want to point out that we normally do, okay. We usually put it, when we put our information in a file, it's a text file, and even the numbers are strings as they're read into the program. And when we are prompting the user at the console, the numbers that they type in are strings, and we turn them into internal number types, either int or float, by calling int or float on them. So we can input all the information as strings. Valid input would be converted into numeric form. We'll use a character-based Sentinel. We could use the empty string. So if we get the empty string, well, then we want to stop. If we get a string that's longer than that, then we want to try to convert it to a number. Okay, so here's some pseudocode. Okay, so initialize the sum to 0, the count to 0. Input the data item as string. He calls this x string. That's not a good Python variable name, but we fix it up later when we turn it into code. And we say, while the input string is not empty, we process it, and then we prompt again for the input string. Okay, so again, priming read, while loop, and then at the very bottom, at the top of the loop, we process the entry that we have in hand, because if it's not the empty string, then we have a real entry. And the next thing we do is that we prompt the user for the next entry. And then, of course, we output the average, but we do it in a more sophisticated way. So this brings up average 4. Okay, so I'm going to bring over the PyCharm version of average 4. Okay, and this has got some problems, and so I refactored it. Okay, and it's cleaner and a little bit longer and a little bit wider, right? One of the things that we've done, again, because we're doing a priming read and we're doing another read at the very bottom of the body of the while loop, well, it's an opportunity to factor that into a common function. So that's what get user input does. You'll notice when we get user input, we say enter a number, and then this enter in angle brackets is to say the enter key, and I guess it means that to some people. So press the enter key to quit. And again, we're using the colon with a space after in our user prompt. Okay? So we initialize our accumulator and our counter. We do our priming read. We have a while where we're checking for the input string not equal to the empty string. So as long as we haven't reached the Sentinel value, we'll keep going. Once we get inside the loop, we know that we don't have the empty string. We convert it with a float. Now, if they didn't give us a proper float compatible value, it's going to blow up. Could we make this more robust by adding a try except block here? Yeah, we could. Okay, and in my supplemental material, I'll show that to you. But right here, we're in the interest of economy of space, we're trusting the user. Then we're accumulating the total, we're counting the count, and we're prompting the user again. And then at the very end, we're either printing the warning or we're printing the average. Okay, so let's give this a run. Let's test this. Okay, and so what happens if we give no input? Well, we get the warning. That's good. And what happens if we give one value of 5.55 and then just a plain enter? Well, 5.55. And then let's do it with 3. Okay, 1.11, 2.22, 3.33, and then a plain enter, and the average is 2.22. Well, that's working very well. Okay, so pretty good stuff. Okay. Okay, so let's talk about looping when the input is stored in a file. Okay, why would we want to do that? Well, the biggest disadvantage of the program that we're developing at this sort of point in its design life is that it's interactive. What happens if we make a typo on uh, entry 43 out of 50? A better solution for large data sets is to read the data from a file. That gives us the opportunity to type the data into a text editor, kind of visually inspect it to make sure that we haven't made mistakes, okay, and then process the file. So here comes average 5. It takes the data from a file. All right, how's that going to be different? Well, sorry. Once I move this thing, it doesn't want to move. All right, so I had to fix up some things in this. This is the author's version. He had a bad variable name for the name of the file and some various things. So let's look at the refactored version, and I'll try to point out things. So at this point in the doc string, even though I haven't read you the details on each one, we've got the same kind of big picture comment, computes the average of numbers, and then we go on to say listed it in a file. And then here's the detail. Uses a for in loop to control file reading. Okay, let's look at that. Okay, so I changed the usual things. Instead of whatever non-Python variable name we had there, I changed that to in file name. Okay, when we did the open of the file, okay, I provided the variable that holds the file name in file name, plus the mode code R for reading, but also in my class we're always including this encoding equal UTF-8, which will give us UTF-8 file encoding, which in the US is a really good bet. And then we initialize our total and we initialize our count. Okay? And then whenever you're reading a file, you can read it with for line in file. Okay? Normally we think as a line as a really big thing. Okay? So normally think, we might have to do a split on that line to get the value that's on there. But it turns out that the float method that's going to convert the string that's online into a float value, it's really robust. And you can give it a whole line. If there's only one value expected on the line, even if the line has a new line character at the end, you can call float on the entire line and you'll get back a float value if there was one there. So we're accumulating that, and then we're incrementing the counter, count plus equal 1. And then we're doing the same thing at the end. If you only got one value, if we didn't get any inputs at all, we're printing a warning. And if we got inputs, then we're printing the average. Okay, and he's given us two files. He's given us actually one file to test with. It's called nums.txt. It's got 5 values. Okay, I created another one that you'll be familiar with if you're in my class. It's called emptyfile.txt, and it's just an empty file. Because I believe that properly testing this means we have to be prepared for an empty input file. In fact, why don't we begin by testing this? So we're going to run this, and it asks us for the name of the file, and we're just going to say emptyfile.txt, and it gives us the warning. Well, that worked very well. And then let's run it with the proper file that he gave us, nums.txt, and we get an average of 25 for the 5 values, and that looks about right. Okay, so again, we keep improving this solution. If you really want this to be useful for a real user to average a lot of values, allowing the user to enter the data into a file and to kind of quality check it and then run it with our average 5 refactored, that's going to be a pretty good solution. Okay. So now in Python, okay, the number of situations in which, and it's almost always the case, okay, in Python, if we want to read an entire file and all the lines in the file, we do what we just did. We use a for line in file, and we process the whole thing, okay? There are some programming languages that don't have a for in, okay? There are also some places that we can be getting our data from that are incompatible with for in, okay? Now, for in works with any iterable, okay? Fortunately for us in Python, as people have created other data sources like connections to result sets come back from a query to a relational database, or let's say we're using the API for Twitter, for instance, and we send a request and we get back a batch of tweets. We have these tweets. What's happened over the months and years is that people who have these interfaces actually build a class that creates a custom object that supports the iterable interface. So the number of times that you have to read something in Python, and you want to read all of them, and you can't use for in, it's getting to be a very small set of times. But there's going to be some time in your programming career, either in Python or somewhere else, where you can't use this kind of for in construct to iterate over uh, all of the input. So how would you do it if you could only read it essentially one line or one item at a time? So the next version of our solution addresses that point. It wouldn't be responsible for us to only teach you how to read iterables, okay? There are things that you might want to read that you have to read one at a time, and you have to check the results to make sure that you haven't run out, okay? Now, if we're going to do that with a file, so we're going to practice with a file, even though we could just use for in with the file, okay? And it turns out that of the methods of the file object, the one that's called readLine, okay, it gets us the next line in the file, and if there is none, if we've reached the end, we get the empty string. So this is going to allow us to illustrate the design pattern that you would use if you couldn't use for in. Okay, so you would do something like this. You'd have a priming read, okay, line equals infile.readLine, okay, and then you'd have a while line not equal to the empty string, process the line, read the file, okay? So you use a while loop, okay, with a priming read. Worked great. Okay. Does this code correctly handle the case where there's a blank line in the file? Because a lot of people go, well, you know, Kevin, if there's a blank line in the file, we're going to think that we're at the end when we're really only on a blank line. And that's because we forgot that we have a new line on every line of a file, even the blank ones. So it's not empty. It's not the empty string. It would be a line would be one character long, and if we examine that character, it would be the new line character. Okay, so we're not going to get an empty string until we really have hit end of file. And when you're reading other kinds of data sources, okay, and I'm going to be kind of vague about that because, again, the number of data sources available where you can't use for in to iterate over them in Python is getting pretty rare, okay? But typically this thing where you do one more read and you get back the empty string, that's usually the Sentinel, okay? So this brings us to average 6. And I'm going to show you that one in PyCharm. Okay, so here's the original code from the author. Okay, and it's got, you know, kind of most of the problems that the last couple of programs had, and we fixed them the same way, and that gives us average refactored. And if we look at that, we can say it's got the same general comment, computes the average of numbers listed in a file, but the details uses a priming read and a while loop to control file reading. Okay. Okay, so what do we do? Well, we get the name of the file and we opened it with in read mode with UTF-8 encoding. We initialize the total and count. We do a priming read. Okay, I'll be back to this in a minute. Now we have the while. You say, well, the line is not equal to the empty string. Well, then, if we pass this, then we process the data from the line we have in hand, and then we read the line again. Now, I just want to point out that I have not factored out this read line into a separate function. And why is that? Well, if we do it, we're going to have to pass in file. Okay? And I don't think that we gain a lot. Okay, I'll just show you what that would look like. So if we just took this code and we said we wanted to refactor, why can't I extract a method? Let's try it again. Oh, it's right here. Oh, we've got this refactor extract a method. Okay, so we take that and we call this sort of get next line. Okay, that's usually what you call those things, and you say okay. And it says I have another one. Do I want to refactor that? Yes, I do. So replace it. This is what this would look like. Okay. I think it's maybe a little better. Okay, but it's pretty complex for only calling it in two places. So I've decided for my sensibilities that I'm not going to refactor those, and I'm going to leave this as technically duplicate code. Okay. And then at the very end, we test if we have real data. If we don't, we print the warning. If we do, we print the average. Okay. So how would this work? Well, let's give this a run. So first of all, it has to work for the empty file .text, and it does. It gives us a warning. Okay. And next, it has to run for nums.text, and it gives us 25. So that gives us the right answers. Okay. And now, did we have to do this? No, we didn't. We did it to illustrate what one does if one needs to read a data source that doesn't allow you to use the for in construct. That's all we're showing you. Okay. All right. Now, we're just going to get a little fancier, and at the same time, we're going to explore what it means to have a loop within a loop, and we call that a nested loop. Okay? So in the last chapter, we saw that we could nest if statements inside of each other. Well, we can do the same thing for loops. Suppose we change our specification to allow any number of numbers, let's call them entries on a line in the file, separated by commas, rather than only accepting one per line. Okay, all right. At the top level, we will use a file processing loop that computes a running sum and count. Okay, so we're going to say, we're going to do this kind of like we just did the last one. Okay, we're not going to use a for in. We're going to use the read line. We're going to have the priming read before the while, and then we'll have a regular read at the bottom of the body of the while loop. Okay, that makes sense. In the next level in, we need to update the sum and the count in the body of the loop. Since each line of the file contains one or more numbers or items, separated by commas, we can split the string into substrings. So now we have to split the string because we might have more than one entry, each of which represents a number. And remember, we said they're going to be separated by commas, not the default value, which is a space. Then we need to loop through the substrings, convert each to a number, add it to sum, and update the count. Okay, so that's how we get a nested loop. The outer loop is going to be the reading of the file lines. The inner loop is going to be the processing of the entries on each line. Okay, and here's what an inner loop might look like. Now, again, Exter is not a proper Python file name. I think this is probably left hanging around from a version of this code that came from either Java or JavaScript, in which these would be fine. Well, these would be valid names. Are they well chosen names in any programming language? I'm going to say not. So we say for entry as string in line split on commas, and then we add the float of the entry as string, and then we increment the counter. Notice that this statement uses line, which is also the loop control variable for the outer loop. In this kind of intersection between the inner loop and the outer loop in a nested loop is a common feature of the way we nest loops. So now we've come to the last of the averaging programs. It's called average 7. And I'm going to bring over that code in PyCharm. Okay, and well, it's got some of the same problems that we had before, plus it's got a chatty comment. These chatty comments are great to remind an instructor to make a point, but they're really not the kind of code that people use on the job. In code that people produce on the job, they use variable names and function names that are easy to understand, and you can just read the code. Okay, having to insert these kinds of comments in professional work product is a crutch. Okay, if we did something fancy or unusual or counterintuitive, would it be important to add a comment there? You bet it would. Oh, okay, but you know, it just kind of running a commentary about what we're about to do. Have the code that does what we're about to do it so clearly that we don't need running commentary. Okay. So the refactored version, you won't be surprised, doesn't have that comment. Okay, so here the details are: uses a priming read, uses a while loop to control the reading of lines, uses a nested for in loop to control the reading of multiple values from lines. Okay. And again, would I put this much information in a program that I was doing in my day job? No, I probably wouldn't. I put them in here because this is a teaching example. Okay. All right. So we're going to take the same kind of approach here. We're going to use readline. Okay, we're not going to use for in. All right, we're going to, the while loop is going to say while line not equal to the empty string. Okay, when we have a line to be processed, we split it on a comma. And one of the things that you can see here is that we never really get full access to the list that's thrown off by split. There's there's a list that comes from the split, okay, and that is the object of the in part of the for in, but it never gets a name. It's a list that's anonymous, okay, and then we process it, and each item in it is called entry as string as we go through, and we convert that to a float, and then we up the count by one, and then of course at the very bottom of the while loop we issue another read. So we have the priming read and the other read, and again I haven't factored these out into a common function. I can see the argument for doing this either way, okay? And then at the bottom, we test again, did we get any data? If we didn't, we get the warning. If we did, then we get the average. So let's just give this a final test. Okay, so again, it should be able to process empty file.txt, and it does. And then we run it again, and it should be able to handle the plain nums.txt that's got one line per. It does, it's 25, so here's nums.txt. I'm not sure I really meant to do that, but I did. So let's do that. Okay, and then the other thing that he has is a thing called nums2.txt. And nums2 has the same values, but he's got 3 lines here. So he's got 2 real lines, and then the new line at the end of line 2 is what causes us to see an empty line 3. So we should get the same answer. It should have the same average because the values are the same, but we should see that it's able to process the multiple entries per line. So let's go back to average.7, which is average 7, and then we're going to run this again, and we're going to give it one more file, nums2, well, 2.txt, and then it said 25 again. So this is a really robust program that can handle an empty file. It can handle a file with one entry per line, or it can handle a file with more than one entry per line. It's very versatile. And again, it has nested loops. The while loop is controlling the reading of lines. The for loop is controlling the processing within each line. And the common thing that allows them to communicate is the variable line. The outer loop is looking at the variable line, and then the inner loop is processing the contents of the variable line. All right, so that's that one. So how do we design a nested loop? Design the outer loop without worrying about what goes on inside. Design what goes on inside, ignoring the outer loop. Put the pieces together, preserving the nesting. And keep in mind that the outer and inner loop usually communicate with each other in the respect that one of the variables from the outer loop is also playing a key role in the inner loop. Okay, so that's how you do it. All right, so we've come to the end of part 1. I invite you to go find part 2, and I'm going to say bye until then. Bye-bye.